The next three talks, the next session, up to 11:15, then we have a coffee break. And I think we have three great talks here, and the central theme is, I think it's about processing. It's about data, and often our data is very, let's say, dirty. We need to manipulate it, convert it, have different views on the data. And what you see in these three talks are basically three approaches, toolkits that you could use as becoming a GIS professional. And the first speaker is Evan Riewol, key developer in GDAL and Proj, I should say, or Goodall, as some other folks pronounce it. And he will take us through 20 years of GDAL Goodall. The floor is yours.
Can we switch to my slide deck, please? It's on. It's displayed. Should I do something? Okay, thanks. Okay, so good morning, everybody. So I'm going to give a project status and focus on the latest GDAL 2.3 version, and with a particular highlight on the cloud-oriented functions. So, yeah. A very quick introduction about GDAL OGR for those who are less familiar with it. So it's a kind of Swiss Army knife for geospatial data that enables you to convert between different raster and vector formats. So GDAL is historically for the raster part, and OGR for the vector side. It deals with, I think the last figure is 250 geospatial formats and protocols. So yeah, mostly everything you need or you can dream of or be afraid of. And it's widely used in almost any GIS. You might have used, of course, most of the free and open source GIS solution, and as well in proprietary software. So on the wiki page, we have a list of more than 100 softwares that declare using GDAL, but it's probably just the tip of the iceberg. And it's licensed with a MITx open source license, so a very permissive one. And this year, we celebrate its 20th birthday, which is quite an achievement, I think. So the latest version, the 2.3, was released in May this year, and we had a first bug fix in the end of June. It was a fairly busy version with almost 1/10 of the total commits since the project start. And there were three major features that have been implemented during this development cycle. First, we we migrated to using C++11, which enables us to write code more easily, and also to drop support for very ancient compilers that were kind of a pain to support. We have migrated from track and Subversion to GitHub. So the past tickets remain the track database, but all new activity happen in GitHub now. And one of those functions that have sometimes some backward incompatibility issue is auto-detection of the output format. I'm sure that many of you have been frustrated when you did GDAL translate my.tif to my.png in the previous version. Your my.png was actually a GeoTIFF file. So now it will do the right thing out of the box. In this new version, we have two new raster drivers, PDS4, which is mostly of interest for those of you who deal with planetary data sets. So it's basically a raw binary imagery format with an XML header with all the metadata, and the driver has the read and write support for it. And the other new raster driver in the RDA is the Digital Globe Raster Data Access, which connects to the Digital Globe REST API and enables you to consume the data they can generate in all their processing chain. We have two new vector drivers, one to deal with Mabog vector tiles, and the other one to deal with WFS3. I will tell you about them a bit later. Kind of technical change, the GeoJSON driver used to deal with pure GeoJSON, but also with other JSON variants like S3JSON or TopoJSON. So now they are split off in different drivers for more clarity and correctness. And yeah, in the MISC changes, the GDAL 2tiles utility is now multi-threaded, so you can speed up your tiling tasks. The Mabox vector tile, so it's a read-write driver, and it handles both variants of vector tiles you can find. So one of the variants is a tile set of files on the file system. You will have a hierarchy starting with the zoom level, and then the x coordinate, and finally the y coordinate, so a set of files. And the other variant is when all those files are put together in a mbtiles container, which is a SQLite database. So for the read support, it can of course read disks, files that are on disk, or it can also access tiles through HTTP. So here I put an example of how you can consume such online data sets. By default, it will clip the geometry of each tile to the exact tile extent, because usually vector tiles have a buffer around them, so that the client can rebuild polygonal geometries more easily. But for some purposes, you don't want to do that. On the right side, you can tune many different things so the zoom level ranges you want to generate, what is the resolution and buffer size of your tiles, which geometry simplification you want to do for the lower zoom levels, and you can also decide to assign some layer per zoom level to properly have meaningful tiles. The WFS3 driver, there was a talk that was mostly focused about that, about PyGeo API, so just a summary of what is WFS3. So it's a significant break regarding previous WFS version. So it strongly relies on REST philosophy, and it's the end of the whole XML management of WFS. So through content negotiation, you can decide to get results in JSON, for example. It's based on Open API, and it has really a minimal core that is easily to implement both on the client and server side. So yeah, the driver is kind of experimental because the specification is quite young. Well, it's stabilizing now, so hopefully things will be more stable. So I will now go to my main highlight for this talk. It's about cloud-optimized GeoTIFF. We are going to do some hand-raising exercise. Who in this room has already heard about cloud-optimized GeoTIFF? Raise your hands. Okay, so maybe 1/3 of the audience. So I'm going to try to demystify a bit what cloud-optimized GeoTIFF is, because it's kind of a buzzword, and I don't like really buzzword. I like to understand what there is beneath that. So we could say that it's a profile of the TIFF format. A cloud-optimized GeoTIFF is just a regular TIFF file that has been arranged in a special way that is web-friendly. So the goal is to be able to access to subparts of the file with minimum retrieval of data and without needing a specialized server. So it's kind of a simple WCS, but with just a file server on the server side. And on the client side, you will use a HTTP GET request using a range header to just download the part of the file you're interested. It's getting increasingly used by various software and data providers. I put a few logos of some data providers, software that are using it. It's growing every week. So just a quick introduction about what TIFF is. So at a very high level, TIFF is a collection of images that are linked together. One image will be typically the full resolution imagery, another one the reduction by a factor of 2, etc. You can also have masks. So, okay. But if you look at the lower level, a TIFF file is really a spaghetti. You have pointers everywhere. You have small section of bytes that can be really everywhere in the file. And if you take a random TIFF file, it's not friendly regarding web usage, because you have to do many small requests of bytes everywhere, and latency can become really a factor that will decrease the performance of reading it. So the cloud-optimized GeoTIFF profile will basically tell you that you must put all the metadata at the beginning of the file, and then you put the imagery. And we decided to put first the imagery of the lowest zoom level, and at the end the imagery of the full resolution low level. So potentially you can stream a code file and have progressive displaying. It might be a usage of a cloud-optimized GeoTIFF. So how do we create such file? Well, with GLAL, for example. So here I start with I create a GeoTIFF file from some source, and then I add overviews on it. And the final step is where I will create the cloud-optimized structure. And the key is this copy source overviews creation options. And with that, it will properly order the overviews and the main imagery, such that all the metadata is at the beginning of the file and then the imagery and in the correct order. Another part is the network virtual file system, because in GDAL you can read files on the disk, but you can also access to remote file, and we have different virtual file system. We have this VSI curl file system that can access publicly available file on the web, and we have added various variants of it to deal with the most popular commercial cloud. So we have support for Amazon, Google Cloud Storage, Azure Blob, OpenStack Swift, the Chinese Alibaba Object Storage service. And they all provide random reading and sequential writing if you need. The most common authentication method are under. I'm not going to go through the details because you have sometimes like 5 different authentication methods that are possible. So GDAL will handle most of them. And we have some small Python utilities that enable you to list a directory on the cloud and copy files into it from it or remove file. The latest QGIS version has a very simple UI to use those remote files. So here it's an example of an Amazon bucket, and you give the bucket name and then the object name, and it just displays in QGIS. In the works that were done in this GDAL 2.3 version, it was optimization to read more efficiently a cloud-optimized GeoTIFF. So here I've done in red the area of interest where you will request pixels. So it's spread over 9 TIFF tiles, and the GeoTIFF driver will realize that actually you just need to do 3 range requests because those blocks and those blocks are contiguous in the files. So it can initiate 3 HTTP1 parallel connection, or if you enable HTTP2, you can use multiplexing to retrieve them. So I put various links that are related to those topics. So there's a website for cloud-optimized GeoTIFF. It's codegeo.org, and yeah, the COG specification is now on GitHub. You have various JavaScript clients. You have COG Explorer. You will have a talk about it later in this morning. You have validation tools. You can put some GeoTIFF file name, and it will tell you if it's compliant with the COG structure or not. Other various changes, we have support for the latest Proj version. We have upgraded to the latest EPSG database version to better identification of EPSG codes in shapefiles, which was a recurring pain. The GeoJSON driver has been largely rewritten to be able to deal with arbitrarily large files. And many other improvements. I will skip a bit. We integrated with this OSS Fuzz initiative, which enable us to identify and fix more than 1,000 bugs. It's really impressive how fuzzing can help you pinpoint particular bugs in drivers. It was really a good initiative. During this development cycle, we are nearly 100 contributors. That's the figure I wanted to underline. So what's next? Well, the future is to raise a barn. You're probably wondering what I want to mean. So it's an effort of modernizing the management of spatial reference system in GDAL, libGTIF and Proj. And it's strongly linked to Proj 5, which offer many new capabilities. So in these new developments, we will finally handle the WKT2 standard, which solves historical interoperability issues and has better support for temporal dimension and vertical components. We'll also use a SQLite database instead of CSV files that existed on the GDAL side, on the libGeoTIF side, and you had this derivative on the Proj side. So all those could diverge very easily. It was not nice. We'll also use the area fuses attached to coordinate transformations. And one of the changes will be the capability to no longer use WGS84 as a pivot system when you have datum transformations, which is something which is nice, but which causes precision loss, and sometimes there's no pivoting possible, so it's just not an option. So yeah, I have to thank all the sponsors of this effort, because it's a huge development effort, and without them it won't be possible. So that's all. Thanks for your attention.
Yeah, thanks very much, Ivan. We have time for some questions. There should be a microphone somewhere. Yeah? Any questions? You can have a question on GDAL in general. Then it was all very clear. Thanks again.